Chapter 8: Environmental Health and Toxicology. While modern medicine may not be responsible for the major increases in life expectancy in the 20th century, health and health outcomes are still critical in our overall health and quality of life. Health is a person's complete well-being. Anything that reduces our level of well-being is called a disease. Diseases affect both morbidity and mortality. Many environmental issues impact our level of health, and these impacts are not necessarily equal across all populations. An illustration of environmental health risks. While many people are concerned with changes in life expectancy, as life expectancy has increased, quality of life issues have also become important. Several measures exist to measure the impacts of the burden of disease on populations. These include QALYs, Quality Adjusted Life Years, and DALYs, Disability Adjusted Life Years. These help to account for the impacts of chronic disease on our lives. Many diseases are becoming more and more important. For example, diabetes has increased drastically in children, although maybe not in adults. Depression has also increased, as has lung cancer and lung disease. While chronic conditions are becoming more important, we shouldn't forget the impacts of infectious disease. While infectious disease has been addressed, there are still issues related to disease burden. Even with modern medications, issues such as poor nutrition, sanitation, and vaccination rates have caused increases in the infectious disease burden. Changes in nutrition and sanitation can rapidly affect morbidity and mortality associated with infectious disease. Infectious diseases are categorized by the infectious agent. These disease-causing agents, pathogens, can be viral, bacteria, or protozoal in origin. Parasites are also important agents of disease in many less developed countries. These agents have the potential for large mortality rates, as seen in the recent Ebola outbreak in Africa. One issue associated with pathogens are emergent diseases. These are diseases that historically have been contained in an area or have not been seen for 20 or more years that redeveloped or expand their range. Globalization has increased the risk of emergent diseases because of the rapid nature and travel across the globe. A map of recent human disease outbreaks. Another reason for the increase in pathogenic disease has been the development of resistance. Many bacteria have become antibiotic resistant, as have many parasites. This is related to the over or misuse of the control agents and the natural actions of selection, increasing the ratio of resistant individuals. Antibiotic resistance. Antibiotics are chemicals that kill or inhibit the growth of bacteria. Many people do not finish the full course, creating resistant strains of bacteria. Antibiotic-resistant strains of MRSA are spreading through hospitals in the U.S. and China, resulting in thousands of deaths. In the U.S., over 19,000 deaths are estimated to have occurred from the 100,000 MRSA infections. At least half of the 100 million antibiotic doses prescribed in the U.S. every year are unnecessary or are the wrong drug. Antibiotics are routinely fed to U.S. farm animals to stimulate weight gain. These are excreted in urine and feces and find their way into surface waters where they create more antibiotic resistance. An illustration of antibiotic resistance. Additional classes of disease-causing agents are toxins. Technically, toxins are chemicals that kill or damage cells. However, toxins are often subclassified as mutagens, damage DNA, teratogenic, cause birth defects, or carcinogenic, cause cancer. It is important to note that by definition, all carcinogens are mutagens, but not all mutagens are carcinogens. How readily impact cells depend on their movement and fate. Solubility is important in the process. Water-soluble toxins are toxins that readily dissolve in water. These toxins move rapidly through the body, so they are less likely to be maintained in the body. However, lipid-soluble toxins, if attached to a carrier, associate with lipids found in cells. Once in the cells, they can persist in the body, leading to more long-term risks. An illustration of toxins on the body. Regardless of the solubility, the route of exposure is also critical. Exposure is typically through one of three routes. These include the lungs, via breathing, through the skin and through ingestion. The route influences how toxic and vulnerable a person is to a toxic. Another issue with lipid-soluble toxins is the concern of bioaccumulation and biomagnification. As you recall, lipid-soluble toxins tend to be retained in the tissues of animals that eat it. This retention is bioaccumulation. Additionally, because of the laws of thermodynamics, less and less energy is available as you move up trophic levels. This means organisms at the top must eat several organisms at lower trophic levels. When combined with bioaccumulation, the result is that organisms at the higher trophic levels have higher levels of the toxin than those at the lower levels. This is biomagnification. One of the reasons lipid-soluble toxins can accumulate is the issue of persistence. This means that the toxins do not break down easily in nature. Some organic compounds, such as chlordane, a pesticide banned in 1988, were very stable with persistence measured in decades. These compounds tend to accumulate and magnify easily. Along with persistence and solubility, most toxins have a dose effect. In toxicology, the dose makes the poison. The route of the dose, then, is important. Dosing can be through an acute event or through chronic exposure. Most health effects associated with toxins are related to long-term chronic exposure. Because of the risks associated with exposure, all toxins are evaluated for their risk of doing harm. The process of developing this risk calculation is called risk assessment. Risk assessment is a process for estimating the risk of exposure. This is done by identifying the risk, evaluating the dose response, determining how exposure occurs, and then characterizing the overall risk. Because of the Delaney Clause, chemicals are evaluated for their risk as a carcinogen. Initially, the risk level was set at 0, meaning a chemical could not be used if it caused cancer. However, because of the issue of the dose making the poison, regulators realized all chemicals may be carcinogens at the correct level of dosage. Because of this, a risk limit was established that allowed for the potential to cause cancer, but at a level in the population that was acceptable. For most people, a risk ratio of 1 case in 100,000 exposures is acceptable. However, to be more conservative, the EPA uses a risk ratio of 1 in 1 million. To put that into perspective, there are approximately 7 million people in Missouri. If you exposed every person in Missouri to a chemical, you would expect 7 or less cases of disease to develop from that exposure. A Venn diagram of risk assessment and risk management.